My name is Emilio Mariscal. I am an engineer manager at HOT. Communities, business, and society as a whole. Maps empower us with information, locating streets and houses today, assessing crops damage tomorrow, understanding road surface, or disaster resilience, or boosting tourism through navigation tools. Today we are going to embark on a journey, and our first stop is imagery. We'll explore how to create our own aerial images even better than those captured by satellites at a fraction of the cost and with increased accessibility. We will use these three simple tools, or almost simple tools, to create high-quality maps. We will use cell phones that everyone have, a computer, and a cheap drone to obtain high-quality geospatial mapping data. For the images, this is the type of images that are available for us. This is S3. Yes, it's not very clear from the projector, but yes, these are the kind of images we have available for mapping usually. But today we have tools like this little thing that enable us to capture images whenever we want at very low cost and without relying on big satellite corporations. Drones are becoming more and more accessible every day. And this, by the way, this is a picture of a fellow firefighter flying their own drones in an activity that we did a few months ago. So, to cover large areas, that is what we want, our strategy involves dividing the area of interest, the AOI, that we want to capture imagery, into a grid of tasks. So we use this kind of grid, and each grid, we call it a task. And what we do is every pilot, like you see here, a list of pilots. In this case, each of them have a different model of drone. There was one case even that the drone had to be flown manually without a flight plan that we will see later. And they started to capture images of each of these small tasks. Like this one. We see here the example of the low quality image, and we will see here the difference between low quality or medium quality imagery and high quality imagery. That is what we can obtain with drones. So these are two different images from two different drones. 10 drones flown that day, and they are combined together to form a single picture. So this way we can obtain images with a resolution up to 3 centimeters per pixel, or even less, depending on our needs, with this little thing that is available here, right here in Belém. You can go and buy one of these ones. To streamline this coordinated flight planning process, we have developed a product that makes image capturing incredibly easy. This is the drone tasking manager. And you will see that this concept of tasking managers I will repeat this same concept on other activities and products that I will show you today. This is dronetm.org, by the way. And all the processed images are then published on Open Aerial Map. This is a wonderful open repository of aerial imagery that allows us to publish and access content from all over the planet and use it in various platforms, including collaborative remote mapping platforms, as we will see next. So we are moving now from image to remote mapping. This is our second destination. Now that we have our high quality images, and you see here an example of what I showed you before, the imagery that we captured with the organized drone flying, and we digitized all the buildings on that image. You can even see the difference between what I was showing you before, where you have this part where you don't see any building, you don't see anything there because it's covered by the trees that are green in that time of the year, and now everything becomes so much clearer, and you can actually see all the buildings by the riverside there, right? So, and the same happens with other areas of this image where the vegetation covered the buildings and now are clearly visible. So we started to digitize, and it's not just buildings, of course. We can see also here with this level of detail, we can identify elements that are very difficult to see in satellite images, for example, an helipad. And maybe it is questionable that we captured the helipad using drones, but we didn't even know that the helipad was there. So maybe it's like some not that official helipad used by emergency services. So that was also not available on the satellite imagery and was clearly visible from the drone imagery. And this is really important for us as first responders and emergency services to know where all of these things are. To map remotely, we use the same strategy that I described earlier. That is, we create a grid of tasks, as you see here, and each of tasks is a task available for mapping. So volunteers around the world can choose one of these small boxes and start mapping there without overlapping their work each other. And also, and there is also a process of validation for each of these tasks, where other volunteers can validate what the first volunteers mapped. This is the HOT Tasking Manager, and this is one of the most valued products that we have at HOT. It's a very mature piece of software that we have been using for a long time now. So now we are moving from remote mapping to this little town that is AI. The question now is, how can we make this digitization process more efficient and intelligent? Well, creating an AI model might sound complicated, and sometimes it is, but at HOT we are working on a tool that allows us to create open models, meaning that we know what information they use for training, what they are made of, and in a relatively straightforward way through a website without requiring expensive infrastructure. The ingredients that we need are images, for example, the images that we captured before using the drone tasking manager and published on OpenAerialMap, and some remote mapping performed by humans. That is, for example, the buildings that we digitized before with the HOT Tasking Manager. So we can combine those two sets of data produced by people and create with that an open model. And also this includes FAIR, that's the name of this tool, includes a process of human feedback where volunteers can validate the results of the model to improve it. We see here an example of the results of testing that we are doing with all the buildings that were detected by the AI tool using a model. And volunteers can go to each of these ones and provide feedback. For example, some of the things that happen sometimes is that several buildings are detected as a single building because maybe they are sharing the roof. So we use that information to improve the model. Not only the model, but also sometimes is to use other tools to improve that geometry to fix it. And we will see this, right now. This is FAIR. This is the other product, FAIR, fair.hotosm.org. And one of the main features of this AI tool is that allow us to create customized models that can distinguish, for example, buildings with unique local characteristics. So a building in Asia is different from a building in Africa, from a building here in Latam, and of course, in each continent also there are a lot of differences. So this, one of the main characteristics of FAIR is that to train models that are adapted, customized to the local areas. Now we continue the journey and we are moving to field mapping, always with the goal of making our work efficient and scalable. We again follow the same strategy of dividing the area of interest in little tasks that can be navigated in this time not digitally, but in reality, in the field, by people walking the streets or the tracks. So, and then, as they are navigating the area, the task, they are completing a form. In this case, we use ODK Collect. That is the tool that we use for collecting data. And this is the tool we are used for coordinating the project. So we have this product that is Field Map Tasking Manager. Again, the Tasking Manager concept is again here. And you see here that the tasks are not agreed anymore. These are for people to walk this part of the area. And then we have this integration with ODK Collect, that is the tool for collecting data. It's not the only tool that we support or plan to support, but we also plan to have support for other tools like Kobo or even other products. Like, I don't know if you heard about merging maps. That sounds a very good use case for us. So yeah, that is how this works. So this is the coordination tool, and we have the integration with the actual apps that are for collecting data into the field. Well, now we are approaching the end of this journey. We are moving to the station download. So what we want now is to make use of this high quality, very complete data that we produced following this workshop. And in this example, we see everything together. This was in Argentina, actually. This is a workshop that we did there for a community that was affected by wildfires. This is the topic that I'm most interested in, of course, naturally, but we also are doing this and I will show you for other use cases, of course. And we see here everything together. We see the background is the aerial imagery from drones. That is very, very high resolution. This is 2.8 centimeters per pixel, I think. And we see here in red all the small buildings that were digitized. We actually digitized the entire town with very, very good precision. Some parts were not captured by the drones because this was performed in 3 days. So we have like a morning for capturing draw imagery. Then the other half of the day was for digitizing using remote mapping. Then in 4 hours we did the field mapping, and then in the third day we did an actual simulation, a wildfire drill to show the people how they can make use of this incredibly amazing data. So we see here all the buildings that were digitized, and all the small yellow points is data that was collected in the field. So here, for example, this little point has the name, Dos Lunas is the name of this place, and the category in this case is housing, commerce, public buildings, and so on. We have the condition, that is the condition of the building, and the material of the building. Actually, these are also tags. This is information that is solved in a way that you can upload this data to OSM, to OpenStreetMap. And that is what we did. And you can see here all the map in OpenStreetMap with all the buildings that were digitized very precisely with the aerial imagery. And you see here all these tags. That is the building material, brick, condition good, and the name, dos lunas. All of that data was collected using ODK Collect in the field. And the coordination tool for doing that was the Field Map Tasking Manager. Field Mapping Tasking Manager. And that is how we obtained this incredible, very detailed map, and that we have also available in OpenStreetMap. Finally, also, as I said before, there is a validation process, and the validation process is all the time there, because when we did the aerial imagery capturing, we reviewed the imagery before upload this imagery to open aerial map and make it available. There was a human review of that imagery. Sometimes there are things that need to be blurred for privacy reasons, or the quality is not the one we want, and so on. So there is a review process, also a validation process. And then when we do the remote mapping, there is a role in the hot tasking manager that is the validator role. So it's people that is peer reviewing all the mapping that was performed there. This is our very experienced mappers that are reviewing the other people's work. And then in the Field Map Tasking Manager, also all the data that is collected to the field, again, was reviewed and before being uploaded to OSM. So there is also a validation process there. And finally, the primary beneficiaries of this map, the community, also plays a vital role in the ongoing validation of the final results, because they are looking into this map and they can say to us, hey, this is wrong, there was a mistake here, or this place changed name and it's not there anymore, or it's closed, and so on. So this is not the end of the process, because the process will continue with the community there. As OpenStreetMap is an open database, all the data that we upload to OpenStreetMap is available for anyone to download in different formats using this other tool that we have available for people, that is the hot export tool, that makes very easy to select an area of interest, select what do you want to download from OSM, and download that data in different formats. As you see there are a lot of formats, like even vector tiles are available, or SQL queries. So you can download the data from OSM using this tool without the need of creating complex queries on Overpass or other tools that are not that easy to use. And this is a web tool, so it's available right away in your browser. And also we are integrating, as this export tool website is connected to an API that we built, that is a raw data API, that is available for doing other kind of integrations. Like, for example, this is a portal of a website from the Mexican government, and they are querying our data and make it available on their website for Mexican citizens. And you see, for example, Mexico airports, and this layer that is available in GeoPackage and GeoJSON. It was also provided by the same API that the hot export tool use. And also we, using the same API and the same software, we publish data automatically into HDX. That is a humanitarian data repository, but OCHA from the UN, which coordinates global emergency response and save lives and protect people in humanitarian crisis. You see here all the like 62,000 downloads of the Humanitarian OpenStreetMap team datasets. So all the data is also available there, and you can see here how from flying this little thing and doing all this workflow, making all this journey to the end, all the data that communities and people produce are available then into several portals and several websites and formats. So we are now at the end. We download data and we are in the map city. We can have now incredible high quality data that we can use, geospatial data that we can use. Here you see all the workflow in a more, in a different way, not in a map like before, and you see that we capture processing and publishing aerial imagery as a first step. Then we do remote mapping, AI-assisted mapping, field mapping. Then we download the map, and then we can use it. And of course, you can use also some of these small steps. You don't need to do the whole workflow. Maybe you already have a good aerial imagery, and you can work with that, and you can do the same process. Or maybe you don't want to, or you don't need to do AI-assisted mapping, or you have another tool for that, and you can skip this step. And the same with, of course, with the other parts of this workflow. So finally, now let's go back to the story that I was telling you at the beginning. When I told you that I took out my phone, I saw that the river was 300 meters where we were at that moment, and I saw that there were houses and a road crossing the river. So we were two groups of people, and to save 2 kilometers of walking, a group of us started to walk to a water stream that we found. The vegetation was really dense. It was like a Vietnam movie. It was like full of vegetation in a small stream of water. So we were walking through this water stream, and we can't see. We weren't able to see the fire, but the sound of the fire was there. Was all the time there, approaching to us. So we started to walk faster until we reached the river, and we realized that was not a safe way for the other people, for the other group of people to follow us. And so what they had to do was to walk 2 kilometers back using a safe way. That was the burned area, and they had to walk 2 kilometers. And in this walk, they don't have any offline maps. They only counted with Google Maps, and there are not internet connection. There are not signal there in these remote areas. So they get lost, and so they have to. There were another group of people that was to the rescue. Finally, they were found. Everyone was safe. But you see here how important and how vital maps can be. They can save lives even. And you see here an example of this is the map of this story. We were in the point up there, and we had to walk to the river. And you see here there are some houses. This is the way that I was talking about. Basically, we reconstruct the story, that story here in this map that is available on umap.osm.org. And these are even the buildings that I mapped some weeks before this incident. And I show you here quickly some of the examples of other workshops that we did following the complete end-to-end process. This was in Pokhara, Nepal. This is a typo there. where there are landslides, and it's very important to have maps for that. We have this in Bali. This is another example where we even collected data that is not for OSM, like the population data. This was in Argentina. I showed this before, and this is in Freetown, Sierra Leone, where also an amazing work of even identifying each household, not only the building, was possible because the quality of the data that we produced. So, yeah, you see here all our different products that I showed you before, almost everything, and yeah. That's it. I invite you also to on Sunday, the State of the Map Latam. I will be doing a workshop about this whole process. It's long. Sorry if the time was like short and maybe there is no time for questions now, but I invite you also to participate into this. It will be a 2-hour workshop where we will be looking into this whole process. Thank you very much.